Alright guys, we're going to start off on a unit on similar figures, similar triangles. Now, before we jump into exactly what similar triangles are, let's talk about what similarity means. So we've talked about congruence, right? And our congruence sign looks something like this. I've got an equal sign with a squiggle on top, right? And basically that means they're equal. It's like for shapes though instead of for numbers. Well, similarity has a similar symbol, and it's just one squiggle. So no equal sign. This is also your negate symbol for converse, inverse, contrapositive, but we're not going to use it for that. So what we want to do is when we're thinking about similar triangles, as we want to understand what's going on with the similar triangles. Let me kind of show you something here. Let me zoom in so I get some white space to work with. All right, so let's look at this here. Okay, congruent triangles look something like this. I've got a triangle here, that looks something like that, and I've got another triangle here that looks something like that. Okay, and if I draw them a little better, they look a little more congruent. But basically, they're the same shape, they're the same size. All the sides match up, all the angles match up, and they're all congruent. Similar triangles is actually a little bit more like how your camera works on your phone, where you can take a picture. Okay, it's supposed to be like something congruent, but you can zoom in or you can zoom out and make the picture either bigger or smaller. And so you have the same shape, but different sizes. So, for example, let's say we've got, a right triangle here. Okay, congruency means all the sides and angles are congruent. Similarity means all the angles are still congruent, but the sides are proportional. Okay, proportional means, so let's just say this is 1, 2, and I can't say 3 because that wouldn't work as a triangle. Say 2.5. Okay, actually let me do real numbers here because these are right triangles. 3, 4, and 5. So it could be 3, 4, and 5, and then over here it could be like 6, 8, and 10. They're proportional because I can set up the 3/6, that's a ratio, but I'm going to put two ratios together, 4 and 8, that becomes a proportion. Okay, so I could set these all up, and these would all be true. Okay, 3/6 is equal to 4/8 is equal to 5/10. So similar triangles, big picture here, it's same shape, different sizes. Okay. So let's go ahead and think about our congruent triangles. Okay, how did we know if two triangles were congruent? Well, we either found side, 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 angle, side, angle, side, angle, 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 side, or HL, right? If I had one of those, then I knew that I'd have congruent triangles. We're going to learn about 3 here today for similar triangles. There's actually only 3. That's the only ones you need to know. Okay, so let's zoom out here and let's take a look at which triangle similarities statements work for us. Okay, they've got some activities here that we are not going to worry about so much. Instead, let's go on to our first purple box here. And it's our first theorem, and it's the angle-angle theorem. So if I get two angles that match up with two angles on another triangle, then I know for sure that these triangles will be similar. Now, this is not a similarity or a congruent triangle proof. It only works for similar triangles. And so if I think about this, angle-angle, that includes angle-angle side, angle-side angle, angle-angle angle, all ones that either are or aren't congruency statements. We wrap them all up into one statement, angle-angle. If I know I have two angles matching two angles of another triangle, I know they're similar triangles. And remember, the big idea here is angles are congruent, sides are proportional. Angles are congruent, sides are proportional. So if I've got two angles congruent, I know the third angle is going to be congruent, and then that's going to kind of lock my triangle into place, and then I'm going to have similar triangles. Now, they walk through a proof here using dilations, which is kind of like what we talked about. Remember, dilations are making things either larger or smaller, but retaining the same shape. Okay, we're not going to have to worry about that too much. Let's look at a couple examples and determine if the triangles are similar, and if so, why or why not. So let's take a look at an example like this. Are these triangles similar? And if so, Well, we only know angle, so if they are, it's probably because of angle. So let's see if we can determine that two angles in the left triangle are congruent to two angles in the right triangle. So the first thing I should be looking for is reflexive sides, vertical angles, right? So I do have some vertical angles here. This is going to work similar to our triangle proofs. Okay, I do have some vertical angles. And then look, I've got some parallel lines here. And if I kind of sketch, let's look at that CE line. So if I sketch these parallel lines out, so I've got a parallel line like this, a parallel line like that, and I've got this CE line. What angle pair are these two right here? If I kind of sketch these out further, it might be easier to see. All right, well, they're inside the parallel lines, and they're on alternate sides of the transversal, so these are alternate interior angles, so these are also congruent. So are these triangles similar? Yes, they are. They're similar by angle. Now, if you wanted to, you could also look at A and D are also alternate interior angles because, again, the parallel lines are inside the line, alternate sides of the transversal. So yes, thumbs up, these are similar triangles by AA. Let's take a look at another one. If I can get my, here we go. Okay, so I've got something that looks like this. Do I know for sure that these triangles are similar? Again, we're going to look for angle. So I've got one here. I know angle R, if we were to write this out as a proof, RSV is congruent to angle RTU, or you could say STU, either one's fine, and that's given to us, right? Now, is there another angle I know is congruent for both triangles? Now, let's highlight our triangles to make sure we're looking at the right thing here. So I've got one triangle, my smaller triangle here. And then I've got a bigger triangle here, okay, and the whole thing. I don't know anything about V and U, although I guess I could use these as corresponding angles to prove parallel lines, to prove that they're congruent. That would be a lot. Let's look at angle R, though. Notice how both of them share angle R. What's it called when two things share a piece? Usually we do it with sides. Well, if it shares, it's called reflexive. So I could actually say that angle R is congruent to angle R, and that's just reflexive, and then I have angle. So if we're thinking about the statement sides of my proof, these would be statements, and then the AA would be a reason, but these are kind of like, if we're roughly sketching out what a proof might look like, we would kind of follow these steps. You'd actually only need 3 steps to prove this to be true. All right, let's look at the next two. So we've looked at angle. Let's take a look at our other triangle proofs. And we've got the side, and the side, angle, side theorems. So the side theorem, triangle similarity theorem, says if I have 3 sides that are, now this is important, that are proportional, okay? Or if I can set them up as ratios equal to each other, and they're equal, then I have similar triangles. So if I've got 3 sides that match 3 sides, thumbs up, similar triangles. If I've got 2 sides that match 2 sides, and I have the included angle, so side, angle, side here, remember the angle has to be inside, trapped between my 2 angles, and again, the sides are proportional, then thumbs up, I've got a similarity, okay? So let's take a look at some examples here. Let's see if we can determine whether or not these guys are similar triangles. Let's see, here we go. All right, so here's our first one. So, can we determine if these triangles are similar or not? Well, I notice I've got an angle, right? Right here we've got some congruent angles, so there's an angle. Now let's look at the sides. Now we need to set up the sides in a proportion to see if they're equal or not. So let's look at this first one. Let's look at this MN side. It matches with MR, right? We feel pretty good about that. So I'm going to set it up 4/6. So there's a ratio. Now I need to set up the smaller side, and the smaller side there is 8, right? And how much is the whole other side? Well, it's 8 plus 4, that's going to be 12. Okay, so there's my proportion. Now let's simplify. The left side simplifies to 2/3. The right side, that also simplifies to 2/3. So I find that the sides are proportional. Okay, so I've got side and a side, and I've got an included angle. So yes, these would be similar by side, angle, side. Thumbs up. Works. Let's try another one. Okay. So we've got this guy right here. Do I know if these triangles are similar or not? Well, again, let's take a look. I'm going to set up my proportions. Now, how do I know which side matches with which? Well, I'm going to pick the smallest, 4 over 6. Put medium over medium, 8 over 12. Then largest over largest, 10 over 15. And if I simplify each of these, or I could plug them each into my calculator if I wanted to, if I simplify each of them, we did the first two already, so the third one comes out to 2/3 as well. So notice how each of these are equal. The sides are all proportional. So these would be similar by side, side, side. Okay, so it's very similar to congruent triangles. The big difference here is that here we're dealing with sides that are congruent, or proportional instead of congruent. All right, let's look at two more kind of tricky ones here, and then I'll let you guys get to your work. So let's set up our sides. Left side smallest over right side smallest. Left side biggest over right side biggest. All right, so I end up with 2 is equal to 2. So sides are proportional. I can count them. There's a side and a side. Do we have an angle? We do. Now question, is this an included angle? Is it the angle trapped between the two sides? It is not. This would be angle side side or side side angle. This one still does not work for us. It didn't work for us for congruent triangles, and it doesn't work for us for similar triangles. So even though I've got a side side and an angle, this is no good. So let's look at the next one, the last one here. So once again, let's set this thing up. Let's make sure our sides are proportional. So I've got 8 over, well, it looks like 3, but wait a second. I noticed something here. These are right triangles, and normally if I just had two sides of a triangle, there'd be no way for me to solve for the missing side. But these are right triangles, so I could solve for the missing side, right? So let's do that. Here I've got, we're going to do Pythagorean theorem. If I solve this out, I get x squared plus 6 squared, I'm sorry, 8 squared is equal to, just make that at 8, 10 squared. If I solve this out, I end up with x is equal to 6. Okay? And same thing here. If I solve this out, 3 squared plus x squared is equal to 5 squared. If I solve this thing out, x is equal to 4. All right, so now we can set up our proportions. 8 would match actually with my 4 side because it's the medium side and the medium side. Is that equal to 6 over 3? It is. Is that equal to 10 over 5? It is. So these would be similar by side, 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 or you could actually do side, angle, side if you wanted to include the right angle down here. So that was a little bit of a tricky one because you had to do a little bit of solving to get there. The big portion of today's lesson is identifying proportions for side, 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 angle, side, and then identifying congruent angles for angle, angle. So this wraps up our lesson on similar triangles and proving similar triangles.